people come in as they come in, right? And I'll be checking them in.
Oh, there's someone else here.
Yeah. Hello.
Sure.
So does it work for you?
I am finding out momentarily. I can connect if we got a 3.5 inch or a 1/8 inch adapter there.
Let me see, this one. Okay, we need to move this away.
I need to connect for video, don't I?
Yeah. What do you have?
I can pretty much do whatever you need.
HDMI?
HDMI is fine. Oh, it looks like Jay's in.
Okay, cool. Yeah, we don't have more space than that.
That's okay. Chris, can you hear me?
Let's see here, speaker.
Check 1 2. Check 1 2. Let's go. Microphone.
Yeah, I think it's that one needs to be on the otherwise they just record it.
Display.
Yeah, it's going through that one, I guess. Oh, it's
I think this is speaker headphone. I think it's the right one. Jay's connected now. If I can just get audio. Presentation. Connected there. Connected there.
the only thing is we need to get it on that screen.
Yeah, I don't plug it in there.
Oh, okay, okay.
Let me get this for one first. I can go full screen. Check mine. Trying to go to this right now.
Ah, of course. So if you don't put that in, it's not.
Let me
just.
it shouldn't matter. I can swap things around. Shouldn't say that now.
Hello.
It's going to that monitor over there, by HDMI, which we don't want. Heard that.
Yeah.
Very low. I heard it. That one. It's just the internal mic.
Why do I need it?
Chris, Jay?
Hello?
Test 1, 2, test 1, 2. I hear you, Chris. Hey Jay, how you doing? Okay, I'm gonna try one other thing here, so we can try to get the, they like to try to record it, they have a room recording system, I know you can record it, Chris, but hang on 1 second. Can you guys still hear me?
Yeah.
Perfect, okay. I'm gonna go get a different adapter. I think if we plug that in, it's gonna assume that's gonna go audio. So let me get my micro HDMI to VGA.
Okay.
Just to see if that works.
Yeah.
Fair?
Okay. Chris, you in Austin?
Yeah, I had 3 canceled flights yesterday, so.
I just turned on the audio because
Oh, they were talking?
Yeah.
Sorry.
It's kind of strange, right?
Yes, it is.
So are we kicking in 5 minutes?
Let's see what
Probably just turn on the audio again.
we kill that one, so there's no, is it projecting?
Yep.
Kill that, so there's not a bunch of notifications.
Yeah, that's it.
You did it over here?
Yep.
Perfect. Chris, Jay, can you still hear me?
Yeah, can you hear us?
Okay.
Okay.
We've got it figured out.
Alright. So Jay's got control of the presentation. We'll let him drive from his side.
Guys, just go on mute for the
hey.
time being. You're actually speaking to the entire audience right now. So just go on
Yeah,
mute.
yeah, I'm good.
When this kicks off, we'll pull you back in.
Yep.
Okay, that's fine. And are you going to kick it off, Dana?
Arnold's gonna kick it off.
I'm gonna get kicked
Okay,
out and
perfect.
give it over to Dan.
Okay.
Cool. Okay.
Yeah, you've got a blog also, right? Oh, yeah. So just say that we're. Yeah, absolutely. Go ahead. Yeah, absolutely.
So, Jay,
We're ready to go.
okay.
So, I'm just going to introduce Jay.
I'll
You do your thing.
do the first introduction and then. Yeah.
Just wait for Alex to be ready as well. You ready? Okay, thank you. Thank you all for being here. I know it's been a bit of trouble for people to come here. If you're from this town, you probably are okay, but yeah, some people that needed to show up didn't show up because of the weather yesterday. Thanks for being here. We'll start with Cloudistics. That's one of the teams that had people flying in, but they couldn't be here, so they will do video stream live to tell you more about their products and what they can do for you. So it's up to you.
Thank you very much. Hi everybody, I'm Dan from Cloudistics. Jay is one of the unlucky folks after my 14-hour trip here yesterday. My unnerving coming into a snow-covered field anyway. That was the first for me. Anyways, great to be here. Thank you for having us. Jay was the unlucky person who could not get out of DC yesterday, so he's from the West Coast and he's at least on the East Coast, but he couldn't make it. So Jay's our chief scientist. Jay has a fantastic background. He's a visionary in the field. He was a fellow at IBM, a CTO at IBM, and both Dell. And one of his claim to fame is he contributed to the copyright and patent on RAID 6. So when it comes to storage, he's got an amazing mind and amazing vision. So Jay, without further ado, I'm going to turn it over to you and let you rip.
Okay. Okay, thanks, Dan. I didn't hear most of that, but thanks for the intro. And I'm very excited. Unfortunately, I'm sorry that I couldn't be there in person. I did try. I think there's a hotel room that I'm not sure we're able to cancel out of. So I think we're probably still paying for it, but we tried. I'm glad Dan is there. But nonetheless, we're very excited to tell you about Cloudistics and what we're calling a cloud software appliance. So let me take you through, see, do I have control here? Okay, here we go. So here are the key messages from my 30 minutes here today. You know, the first thing is, the way we look at it, cloud is really not a place, it's an experience. And, you know, it'd be nice if we could change cloud to be an adjective instead of a noun. So you can get it on premises, you can get it hosted, or you can get it in the public cloud. And you'll see that from a Cloudistics perspective, we have focused a lot on the experience. Because that's our point of view on what it takes to be successful in this space. Public cloud is a great thing. Lots of workloads are moving to the public cloud, but we don't think that all workloads will be in the cloud someday in the future. And I'll talk a little bit more about that. You know, depending on who you believe, it's anywhere from 20 to 25% today. Just depending on who you believe, it'll be 50, 60% by 2025. We don't think it'll be 100%. It'll be significant workloads running in data centers and in edge clouds. And so we'll talk a little bit more about that. Clearly, some workloads are going to be better in the public cloud. Others are going to be better on-prem. Our own view, and I think shared by a lot of people, probably a lot of you in the audience, is that in fact the future is multi-cloud, hybrid, etc. Cloudistics itself is a cloud software appliance. Our value add is in the software. We run on standard commodity hardware, but we ship everything together, the hardware, the software, and everything you need to be running your application, so you can be up and running in under 2 hours after the box is racked and cabled. So we are a private cloud, moving in the direction of multi-cloud and hybrid. Some of those items are available now, others are in the roadmap, but that's our vision. So this, this next chart, I think, is pretty telling. It tells us about where we need to focus. You know, if there's a lot of complexity, there's a lot of opportunity to get rid of complexity, and I think this is what Amazon has shown over the 12 years or so of its existence. You know, compared to a lot of players that are still thinking about infrastructure, but have not really figured out how to simplify that management of that infrastructure. So we, in Cloudistics, we're focused on the app, not the infrastructure, and we'll talk a little bit more about that as we go forward here. So here is the agenda, and there's a reason for this agenda, because when our founders started this company 3-4 years ago, it was driven by their own personal experiences. From their previous company, they were trying to set up a test and dev environment and do other things, and they started with the public cloud, ran into issues, started to move towards on-prem offerings, ran into a different set of issues, and then Cloudistics got created. So I thought I'd walk that same story with you, because that really is how the company came to be. So let me start with a little scenario that I'm calling Cloudonomics here. And some of you will be quite familiar with the story, but I thought it was worthwhile, because it really does share our experience as a company. So the little example I want to take you through is a little retail shop, a small growing business. It needs a few Windows machine, virtual machines, and it begins its operation by running 5 days a week. And because of tight cash flow, they like the OpEx model, so they start with Amazon, and they run, 10 hours a day, 5 days a week. And of course, there's no capital cost. There's a bunch of operating costs for the 10 VMs. You see on the right of that slide some assumptions about, what kind of virtual machine they need, how much RAM they need, etc., how much shared storage, etc. And the numbers that you see here, this is sort of the reason why a lot of people start with Amazon. It costs less than $1,000 a month to get going for this company. And by the way, these numbers are straight from the Amazon, monthly calculator. And I just ran these numbers sometime in January. I've been doing this for 2 years, just tracking what their numbers look like. So I always refresh because these numbers change all the time. So these are pretty current numbers, and this is what it'll cost for this little company to run their 10 VMs. About $1,000 a month, $12,000 a year, very reasonable, and this is why they get started the way they did. Of course, if you run 24/7, if you forget to turn off your virtual machines at the end of the day and run them 24/7, it's a little bit more expensive. It's $3,200 a month. Still pretty reasonable, $36 a year. So then I continue the example here on the next slide. The company grows a little bit. They need 20 VMs instead of 10. The cost goes to $6,000 a month. But I introduced also a 5-year projection in gray. So you'll see that over 5 years, the cost is close to $400,000 for this small little retail shop. Now they expand to the West Coast. So they have 20 VMs on the East Coast, they have 20 VMs on the West Coast, and now the 5-year cost is, $800,000 or so. So it's starting to build up. The next is, because of the cost, they moved to use of reserved instances on Amazon to bring the cost down. That saves them about $100,000 a year, and so they're at $666,000. Now, the company becomes more successful, so, their one shop becomes 10 shops, their 10 VMs becomes 100 VMs, and now, if you look at the 5-year cost, that's pretty significant. Now we're talking $3.7 million for that one shop becoming 10 shops, with again assuming 50% of the VMs machine instances are using reserve pricing to get a good break. And even if I turn 100% to reserved instances, it's still over $3 million over the 5 years. And this is sort of the experience that our founders had. After a while, they really found that their costs were really very much more significant than they had thought it would be. Easy to get into, but costs can quickly grow. And this is fairly basic. I'm really not counting cost of backup and moving data around. Fairly simple. Just run the VMs to sites, to locations. Now, what would it take to do all of this on premises in your own private cloud? And you can see that you can save significant amount of money. Some of these numbers are obviously from our own product, but I show a range that's there because there's others that claim the same kind of cost advantages. And that number really includes, the hardware, the infrastructure software, in our case, all of the upgrades to the software over that 5-year period, the power of the cooling. We use a generalist rather than specialist to manage our things, and 5 years of service and support. So, really, it's pretty inclusive And even if you don't, if you think we've forgotten something here, you can see that the difference is pretty significant. And this is really what, what led our founders to start thinking about, can't we do better? We love the experience that Amazon is giving us, but we certainly don't like the cost, and there's some other issues. If you look at this next chart, the public cloud is great, but it isn't perfect. And, cost is certainly one issue. Others of you might be worried about lock-in. Others of you might be worried about compliance or where's my data, etc. And so it's great for many things. It's not perfect. And so what the Cloudistics journey was about, trying to replicate all of the good features down the left side, the agility, the low cost of entry that you just saw, the OpEx model, great scaling, all of those kind of things, without giving up on cost or performance or some sort of control. So when they came back and they started to move into the data center, this was sort of the state of the world. And the picture on the left, this is sort of the siloed way of the data center, where you buy your servers from Dell or HP, you buy your networking gear from Cisco, you buy your storage from EMC or NetApp, and kind of put it together. A lot of people still do things this way, and the main challenges are the high cost and the complexity of management. And so this is what the founders found. I mean, they did use VMware, they used EMC storage, etc. The picture on the right are the converged offerings that came out in early 2000s from Cisco with VCE and FlexPod, NetApp FlexPod, which solved at least the time to value, because you kind of got your server, your storage, your networking all together, integrated, pre-tested. But the costs and the management remained problematic. And I think this was true until things like hyperconverged came along. So I think that this first and second generation is focusing more on the hardware. This next generation with hyperconverged really focused on the infrastructure software, and they really did attack the cost and management issues quite well. And I think we're seeing the success of many of these companies that you see listed on this page. Some have been acquired, as you know. HP bought SimpliVity, and Cisco bought Path, and so on. Others obviously are doing very well on their own. And so I think I think the cost and management aspects were well addressed. I think there are other issues with the hyperconverged architecture. For those reasons, our architecture is not strictly hyperconverged. Because of the way the scaling works and the compute and the storage kind of go together, that chain block on the bottom of the chart is trying to show that you sort of scale these things together. There's other kinds of issues. It's not perfect, but I think it did go a significant way towards addressing and making it more likely that people will look at on-premise offerings as competitive to what Amazon and others provide in the public cloud. So when we started Cloudistics, that was sort of the starting point. Actually, this project probably started in parallel, but a few years behind some of the hyperconverged offerings. They were not widely available at that time. I think they came a little later. But if you look at what Cloudistics is, it's a full cloud software appliance, and we want to move the focus all the way to the apps. The first and second generation, the focus was on hardware. Next, the focus was on infrastructure software. In our case, the focus is on the apps. And so we start with the hyperconverged like picture. You get to your servers and storage. you get your compute virtualization. In our case, that chain lock is missing, as you can see on the right. We let these things scale independently. They're not tied to each other. So you get just as much storage as you want. You get the amount of compute you want. We don't tie them together. But in our opinion, you know, we don't want to, if you really want to focus on the apps, you've got to take care of more of the infrastructure. So in our case, the hardware that you get is not just servers to run your compute and your storage. You also get a pair of switches and routers. Again, it's all open networking and switches, and it's you know, commodity stuff. There's nothing special about it. But in our case, we want to make sure that we don't leave it to chance. You know, if our nodes need to talk to each other, our nodes need to talk to storage, we know what's needed, and so we provide what's needed. We also provide the virtualization on the networking layer. So this is similar to VMware's NSX offering, except we do have a different way, a more patented way of doing it, which is line speed, a type of performance. But it's that kind of capability, overlay networking that simplifies the application's ability to be agile, to be moved around, to be mobile, without having to change network ports and IP addresses and all of that kind of stuff. And it's all integrated into the product. It's not something you buy separately with a different user interface and a different UI. It's all built in to the product. We feel that this is what it takes to make the hardware as invisible as possible. You've got to do these kind of things. On top of that, there's also software that lets you focus on things like multi-tenancy, metering, self-service, all the cloud-like attributes that we have grown to love, and an application marketplace. And so all of that stuff on the right is really part of what you get when you get Cloudistics. And it's our view that what we want customers to worry about is the stuff at the very top, which is the application. And all of the stuff underneath it is really strong, really robust, really secure, really complete, but we worked very hard to make that part of it all as invisible as possible. So we'll talk a little bit more about that. So the idea is you bring this thing in, you plug it, you get it ready to go, and in 90 minutes you should be able to start running your first application after the racking and cabling. And a lot of that can be done on our side before it even reaches the customer, because you know we have the switch as part of what we sell. So what we want is kind of the performance and scalability that we were used to, you know, pre-hyperconverged with a converged-like offering, but you want the cloud-like experience, and it's all about the app. And that's kind of what Cloudistics is all about. So let me talk a little bit more about Cloudistics, and then we'll kind of wrap up. So what is Cloudistics? And you know, by analogy, I mean this could have been Google or any of the other public clouds, but I think you know we just picked Amazon here in this picture because people know about elastic block storage and elastic compute. And we've got, as you can see on the right, which is our Cloudistics cloud software appliance, all of the same kinds of things. So you're really getting everything you want, if you will, in a box, and then you've got two things to connect. You've got to connect to the internet, and you've got to connect to power. But if you look at the layers of what we have, we've got all the same layers. All the way up to the application marketplace at the very top. And in our case, we actually manage this offering as a SaaS portal. So it's actually managed from the cloud, which we think is one of the ways in which we really make this thing give you a cloud-like experience. So there isn't a separate set of compute nodes to run a portal. It's all in the sky. We let you New software upgrades are pushed and automatically taken care of. Remote debugging is possible, and the whole thing can be managed without any specialist. So a generalist can manage all of this stuff. We have separate roles. We have a role for the person that just manages the app. There's a separate role for managing the infrastructure, which can be a simple generalist, but we make it so simple that the customer can do it or we do it for you. So one of our partners can manage the infrastructure for you and the customer just manages the app. So in that sense, it's very much like the public cloud. So we like, no hardware management. We rapidly deploy apps. It's also multi-tenanted, just like the public cloud is. So if you're a large corporation, you want to carve up for your different departments, different functions, or you're an MSP and you have multiple clients, the same cloud software appliance can be used. We provide the multi-tenancy with that. Now, there's a lot of innovation in these layers of the stack. I mean, we're not using traditional techniques. I already mentioned that the way we do network virtualization, for example, is different. That was important to make sure we get line speed performance. So if you have a 100 gig physical network, I want to make sure that the 100 gig virtual network that's layered on top, you're not losing performance because of that virtualization. The way we do scaling of our compute and storage, this is all scale out, but we do it in a clusterless way, not using traditional techniques of clustering. Again, I don't want to get too much into the details, but the reason for doing some of those things is to avoid some of the limitations of clustering. So if you really want to scale beyond 32 or 64 or whatever a number of nodes you want, which many clustered systems have that kind of issue, we'll let you scale beyond while avoiding some of the traditional issues with clustering where you could lose all the data in a cluster, and in our case, our architecture avoids those kind of issues. So there's a lot of sort of secret sauce in this picture in each of these different layers. And when we started out, there were times when we thought, our performance is so good, we use all-flash arrays for our storage. Maybe that's our secret sauce, or maybe the fact that we're actually very inexpensive relative to some of the other offerings. But at the end of the day, what we've discovered as we've talked to customers, if they bought our product and used it and are running it in production, what we're finding is that it's really the experience that customers really like, and that's been our number one focus. Performance is great, but it's below the experience. Cost is wonderful, but that's also below the experience. It's all about the experience, and what we're finding is the fact that this can be deployed so quickly. There's minimal hardware management. We can do proactive support. We see things are going wrong from our portal. We can fix things. Replacements can be ordered before you even knew there was a problem with one of your servers. We can do remote debugging. The fact that you don't need specialists. All of these kind of things are ultimately the reason we discovered over time that that's what customers really like. So it really is the experience. I'm going to take a few minutes to go through a few of the core innovations of the product. I've alluded to all these, so I won't belabor any of this or get into any technical depth, but the picture on the left kind of shows what a minimum system would look like. It's a 6U system. There's a 2U storage block at the bottom, which has up to 200 terabytes of usable capacity, not including our compression, dedupe, and all of those kind of data reduction technologies. If I throw that in, depends on the workload, obviously. It could be anywhere from a petabyte to 2 petabytes, depending on if you get 5x or 10x or what on your data. But even without any of that, that's 200 terabytes. And we get about 250,000 IOPS with all of the encryption, dedupe, and all of that kind of capability. On top of that, you've got the 2U compute block, up to 8 nodes there. If you want more, you add another compute node block and keep adding a node at a time. We automatically discover new hardware, so when the new hardware is plugged in, it's just discovered. And then we've got the network block. And the network block can support all of the compute and storage underneath it. It can support up to 5 compute blocks, multiple storage blocks, etc. So you can keep adding more storage, more compute. The storage can be added, 1 flash drive at a time. There's 32 in that storage block below there. So that's sort of what the picture looks like. And then the SaaS portal is where all of this stuff gets managed. So if I think about how do we get the experience? These were some of the things that were really important. The portal, having that in the sky, not allowing for any need for hardware management, because when you get this thing, it's all properly connected, all the OS is loaded, our software is loaded, everything is there. And then we do software push upgrades. So in most cases, we can do upgrades remotely and non-disruptively to the customer. We can do remote debug. We have the app marketplace that we talked about. So we've got, things like Splunk and Hadoop and other enterprise apps. There's a long list of apps that are part of our marketplace. Click and run, and that's kind of the idea. The virtual networking, important to get agility for your application, security for your application, because we do things like microsegmentation, so you can segment the app. And then mobility, we certainly support VLANs, which is the traditional way of doing stuff, but as you know, there's limited mobility that you can get with VLANs. VNet, virtual networking, which is what we do, in addition to VLANs, gives you that mobility. We do the clusterless federation, which gives us better scaling and better performance than clustered systems. And we have true multi-tenancy, so it's not just that each customer gets their own separate set of hardware. Within, you can carve up the hardware and still isolate tenants within that in a logical way using our microsegmentation and other kinds of features. So as you add more tenants, there's no need to go muck with the underlying network ports and stuff like that, because we can do it all with the overlay networking. So those were some of the things that were really crucial to the experience. I mean, these are all innovations in their own right, but they're not, we didn't do networking because, we wanted networking. We did networking so that the experience for the customer was important. So I've got about one chart on each of those 4 innovations. The picture on the left here shows a flex pod. And the picture on the right is really our Cloudistics marketplace. I mean, we're focused on the application. That's what we believe is important to the customer. We want to hide all that stuff on the left and make it as simple as possible. This is sort of a picture of our virtual networking. Again, I don't want to get into the details of how it works, but really you have the underlay network, which does not have to be changed as apps come and go. On top of that, you have the overlay network. That's the thing that can come and go, but you don't have to touch the physical network. You don't have to muck with the ports and all of that other physical stuff. And so you get the agility, you get the mobility, you get the security at your application level. And then finally, this notion of the logical multi-tenancy, and the way we do that, for those of you that have used VMware, it's sort of like VMware vCloud Director, where you can take a single cluster and then carve it up for multiple tenants. It's a similar kind of idea. You have these physical pools of compute and storage, which we call a migration zone, but then we virtualize these things into 1 gig RAM units, 1 gig SSD units, and 1 gig, 1 vCPUs, and then we create these these tenants that have these virtual units in them. So we call them virtual data centers, or VDCs, and you can have multiple tenants or multiple VDCs, and that's our approach to supporting multi-tenancy on this product. But the way that we have a lot of flexibility in how you consume Cloudistics and how it's priced. You can certainly buy Cloudistics and put it on your own premises. A lot of our customers do it that way. And it's easy enough to manage. But if you prefer, one of our partners can manage the hardware for you, and you just manage the app. We also offer a hosted way, and then it can also be consumed as a service. And similarly, in terms of how it's priced, you can buy it up front, or there's sort of a model that's similar to reserved instance pricing, where you pay a little bit up front, and then you pay for use. And it's targeted more at MSPs currently. No reason why over time that couldn't be used more broadly, but today it's more targeted, at the MSPs. So I want to just come back to, there's a lot of technology here, but it's under the cover that's all hidden. And at the end of the day, what we're finding is that customers are buying Cloudistics for these features. It's really the experience. It's the fast deployment. It's the minimal hardware management. It's the proactive support. It's the fact that I don't need a compute specialist and a VMware specialist and a Cisco specialist and so on. I just need a generalist to manage all this stuff. So I think I'm getting. I think I've taken about 30 minutes. Hopefully, I know we started about 9:30 or so. So I'm going to try and wrap up here. I want to come back to where I started with the public cloud, we are. Depending on who you believe, somewhere from 20 to 25% of workloads today are in the public cloud. And there's all kinds of estimates about the future. VMware's estimates, Lenovo's estimates, some are more aggressive than others. I'm not afraid of throwing in my own estimate. I used to work in IBM research for a long time and used to go around prognosticating myself. So excuse my own estimate thrown in there, but I don't believe that we're going to see more than 60% in the public cloud, and I think that's because of a combination of things that you see there. First of all, the cloud experience on your own premises is improving with products like Cloudistics and others, and I think that will cause many workloads to use the private cloud and kind of get the experience that you're used to on the public cloud. And certainly on the public cloud, we talked about some of the issues with cost and compliance and performance. That will be okay for some workloads, not so for others. And finally, I think, and I think many of you know this, I think many of our future workloads will need computing closer to where the data is getting generated. The idea that a self-driving car can take a video or a photo of a stop sign and send it to your main cloud and have that analyzed in time before you hit the intersection. I think those kind of things are examples of reasons why there will be more stuff at the edge. And so, if you assume 20% to private cloud and 20% to edge, that still leaves only 60% for the public cloud. So I'm fairly confident in my personal estimate there that there will be, there'll continue to be more movement to the public cloud, but it's not going to be, the world is entirely in the public cloud. And the kind of considerations you have to take into account to decide where you place your workload, are these. I mean, if you have elastic workloads, clearly they belong in the public cloud. But more predictable ones can be done in the private cloud in offerings like ours. There are other considerations, the amount of data you generate, what are the other apps you're integrating with them and with your app, and are those other apps in the public cloud or are they on-prem? All those considerations, and there are obviously business considerations that will decide, you know, what is your business policy regarding data outside a firewall? You know, do you like OpEx versus CapEx? You know, where's your end users and how far away are they from your data centers? All of these considerations obviously will play a role. So it's not going to be 100% one way or the other, is of course the point. So our summary here is that you'll have private, you'll have public, you know, and clearly hybrid is an important thing, or multi-cloud is an important thing. We're seeing that, you know, with what VMware is offering now on AWS. We're seeing that with Microsoft and what they're doing with the Azure stack. And you know, we want to do the same thing. You know, we have the Cloudistics private cloud software appliance, and we're beginning to connect it to many different public clouds for people that want to manage it all from that user experience I showed you with that screen. A simple way to manage it all. You know, I talked about these migration zones. You'll have migration zones that are on-prem, and you'll have migration zones that are on AWS. And other places, and you'll be able to manage it all. I mean, that's kind of our vision. We're a private cloud today, moving to a hybrid cloud, as I mentioned earlier. So I think this is my last chart. I mean, I think public cloud is great. I don't think it's perfect. I think the on-prem cloud experience is improving. Things like our application-focused appliances, cloud software appliances is emerging. Clearly some workloads will be better one place, some will be the other, and customers will want that choice. And so the future is going to be multi-cloud and hybrid. So hopefully that's been a good introduction to you. I know Dan is there, and you know, we'll be able to answer more questions for you. I missed the fact that I'm not there in person. Hard to gauge audience reaction when you're talking and you're not seeing the eyeballs, but you know, that's the way it turned out. I really did try to be there. So I'll stop there and turn it back to all of you, Dan, and take it from there.
Thank you.
Thank you, Jay.
Yeah, thanks, Jay. We unfortunately don't have time for questions, but both myself and Chris are here all day. Happy to address any questions you may have or get you in contact with Jay. Thank you.
Okay, all right, yeah. Sorry I couldn't be there to take the questions. I would have enjoyed the interaction. All right, thank you, Dan. Appreciate it.
Take care, sir.
Thank you,
Bye-bye.
everybody.
Thank you. All right, I don't need a mic because I talk really loud, and if you need coffee before, you won't need coffee anymore because I'm a loud talker. You're welcome. They should have had me up first. My name is Keith Townsend. I'm the principal and co-founder of the CTO Advisor strategic IT company, and we help
IT vendors get out their message. You might have seen the CTO dose on either YouTube or Twitter, etc. Visit the website. It's ctodose.com to check out some of the interviews that I've done. We're actually a couple of the sponsors of Tech Unplugged, so I appreciate the opportunity to come here and talk to you about container orchestration landscape. This is one of those areas that, as IT infrastructure professionals, we're kind of interested in, where we've looked at it. Containers are a thing one day, not so much the other. So I thought I'd start the conversation talking about what are the drivers for containers. If you've been in IT for any point of time, we remember the OpenStack days. This concept that Cloudistics just got through talking about it, that we're going to build this private cloud in an enterprise that we can extend out to the public cloud, and we have this multi-cloud environment, this hybrid cloud. It's going to be controlled by OpenStack, and things are going to be great. You know what, for various reasons, from a technology perspective, from a vendor politics perspective, from an open source project perspective, it all just flamed out. And this container movement was kind of birthed out of the failures of OpenStack. The idea that we can give developers these compact environments that they can put on their laptops, generate code, package that code, take that same package and run it in enterprise IT infrastructure at scale. At the end of the day, IT infrastructure professionals, all we want to do is create infrastructure, whether that's on-prem, in the cloud, software-defined, hardware-defined, it doesn't matter. We just want to create infrastructures that our developers and application teams consume. I talked to a big Fortune 500 size professional services firm. They spent a lot of time deploying Microsoft's pre-Azure stack platform globally. Spent millions of dollars deploying it. At the end of the day, no one came. The experience wasn't what developers looked for, therefore they abandoned it. The hope is that container and container orchestration allows for this easy application development, application deployment, application management infrastructure. So we create the application on a laptop, package it, send it to a cloud orchestrator to either run on-prem, off-prem, or a combination of the two, and we can manage the infrastructure in a way that we're accustomed to, or at least we modernize our infrastructure operations in a way that's manageable. I've had customers build fabulous applications in the cloud. Go to turn those applications over to the infrastructure team to manage, just for the infrastructure team to say, no thanks, too much of a snowflake, we can't manage this because we don't have the team and the resources to do that. Cloud orchestration or container orchestration is the hope that we can get past this barrier of easy development alongside of easy management. And I use the term easy lightly. So first, let's talk about the orchestrators of orchestrators. What's the big picture? Who's the big major players in cloud and container orchestration? The big guys are Kubernetes, and we'll talk about specifically a subset of Kubernetes. There's kind of a branch off in the Kubernetes space. We're talking about Amazon's web services. I'm lumping they have a couple of services. They have an Elastic Container Service. We'll talk a little bit about that. And then Azure Container Services. We'll talk about that, which is also a little different. Then also we have Mesosphere. We'll talk about Mesosphere. They're a data center orchestration tool. And then Docker Swarm. So first, let's talk about the non-Kubernetes play, because this is kind of like the precursor to Kubernetes, and Kubernetes has more or less kind of taken all of the air out of the conversation. Even the non-Kubernetes platforms support Kubernetes today, or there's plans for support of Kubernetes. So let's get out the non-Kubernetes platforms out the way first. Mesosphere, which is 4 years ago the most exciting vendor in this space. Mesosphere had very ambitious goals. Their idea was to create a single data center out of multiple, or not a single data center, but a single compute layer out of an entire data center. So the idea was to abstract away the data center so much that instead of developers and operators programming to storage, compute, and networking components individually, like, I have my VMAX away, I have my HDS, my Hitachi HDS, I have my VNX, all different layers of storage, along with HPE compute. Compact is gone, so that dates me a little bit. I love using Compact as an example. I love that platform. But Cisco, Dell, all these different layers of compute, all these different layers of interface. Let's create a single interface, a single API to the data center. Containers was just a subset of that strategy. So Mesosphere has always had this idea of container orchestration. So strong that Netflix actually adopted Mesosphere as part of their container strategy. Instead of adopting Kubernetes, Netflix built their own container orchestration platform called Titus. I highly recommend just Googling Netflix Titus. Netflix did a great job of putting out about a 25-page paper on Titus. It talks about their journey to containers, some of the drivers they had when it comes to why they wanted to package their applications with containers, manage them, some of the operational challenges they ran through, all very much applicable to your container journey. If you're thinking about doing containers, while we sometimes look at hyperscalers like Netflix and say, oh, you know what, our data center isn't like Netflix. Netflix had a lot of challenges that looked a lot like the challenges that we have in the enterprise. Second non-Kubernetes player in the space is Docker. So I went to DockerCon EU. Developers love Docker. I was at DockerCon EU, and some of the tweets were, I wish we stopped talking about these old man technologies and talk about the new stuff, which is containers and building applications, and why are we talking about modernizing applications when we're just talking about greenfield? Well, Docker learned that, you got to pay the bills somehow. Developers don't have a pocket full. The operations guys, the infrastructure guys are the ones who are able to sponsor these types of projects and move them forward in the enterprise. And container, with the onset of OCI for the base container image, there has to be value over packaging applications in containers. That value is Docker Enterprise Edition. And part of that package when you purchase Docker Enterprise Edition is Docker Swarm. It is the container orchestration platform. We'll just leave it at there's a lot to want when it comes to Docker Swarm. It's just not, when you compare that to Kubernetes, it's just not as mature and not as feature rich as the Kubernetes platform. So this can be interactive. If you have questions during this presentation, raise your hand, we can have a conversation. But that's it that we're going to talk about, the non-Kubernetes platforms as it pertains to their features and capabilities. We'll revisit both Mesosphere and Docker Swarm, I think, a later point in the presentation as they pertain to Kubernetes. So these are the platforms that we're going to talk about from a Kubernetes perspective. OpenShift, VMware PKS, Docker Swarm. I still misspelled Swarm. Swam. It happens. AWS EKS, which is in preview, Azure Container Services, and Google Compute. Just a note when you're presenting, if you ever have to present, if you have a projector at home or in the office, do this. This is like you find stuff that you never find until you actually present. That's weird. So let's first talk about OpenShift. Who's heard of OpenShift? Like, and it, one person. Well, two people. Oh, three, thank you. I mean, OpenShift has been around a while, much longer than the Kubernetes brand. Matter of fact, when OpenShift started to talk Kubernetes, it confused me a little bit because I'm like, wait, hold, isn't OpenShift a Red Hat's PaaS platform? How is it now a Kubernetes distribution? For those of you who don't know, I think I kind of fast forward the conversations a little bit. Kubernetes itself is an open source project originally sponsored by Google. Google has always run containers at scale. They've open sourced their kind of that back end process and back end set of tools and provided that to the CNCF, the Cloud Native Compute Foundation, which is hosted by the Linux Foundation. And now, just like Linux and other open source projects, the community can take upstream versions of that and create their own distributions. You would probably never ever take Kubernetes and deploy the upstream yourself without support. I think Kelsey Hightower has a book out called Kubernetes the Hard Way. So if you want to really experiment, but like in production, you would probably go to one of these vendors we just mentioned and get full support for Kubernetes. Red Hat, being the open source company, is their top tagline, came out with support for Kubernetes with OpenShift. The thing to know about OpenShift is that it predates Kubernetes. It is a platform as a service. It competes directly with Pivotal Cloud Foundry. If you've heard of Pivotal Cloud Foundry, one of the Dell Dell Technologies companies, it is a ready-made, what we call an opinionated PaaS. You bring it in-house, you bring Cloud Foundry developers in, and they're able to get started up and running. You don't have to look out and buy these PaaS microservices that like SAML, for authentication. You don't have to look at message buses and determine what APIs you're going to make for message buses. These PaaS platforms make it super simple, but they're opinionated, which means that developers have to do it this way. OpenShift is one of these PaaS platforms. They have adopted Kubernetes as their container orchestration platform. So if you want platform as a service and you want to build your applications in containers, you choose something like a OpenShift, and then that also comes with container orchestration support with Kubernetes as that backend. So the ideal is to hopefully throw a bunch of this overview information to you guys. If you have questions, again, pause. We can have a conversation, we can talk through it, but we only have 25 minutes and we're going to go through an awful lot of vendors in that short period of time. VMware PKS. So I've had a conversation with these guys. And for an extended conversation, I think it was almost 20 minutes. Go to the CTO dose. I challenged VMware on this. When I think of containers and I think of cloud native technologies, I don't think of VMware. I think of VMware for my steady state, VMs, DRS, HA, Oracle stateful applications. When I think of containers, I'm thinking of stateless applications, the ability to bring up stuff, break it down really fast. So VMware has a really complicated cloud native story in general. They have Photon OS. They have VMware integrated containers. They have now VMware PKS. The PKS stands for Pivotal Kubernetes Service, I believe is the acronym. How does all of that fit together? That's on the video. You can watch that together. But the idea is VMware's concept is that there's no better infrastructure to run containers on than a vSphere virtual machine infrastructure. Earlier on in the container conversation, we had this debate in the industry. Did it make sense to run containers in VMs or to run containers in bare metal? I think today that conversation is over. It makes sense, unless you just need the pure performance, it makes operational sense to run containers inside of VMs. We cannot recreate all the tools that we shouldn't go about recreating all the tools that we've created in our virtual machine infrastructure just for containers natively. If we look at all the big cloud providers, they're not running these containers on bare metal hosts. They're running them inside of VMs. If we look at Netflix and their Titus project, they're not running containers on bare metal. They're running them in EC2 instances. One of the advantages they found with running containers on top of EC2 is that they became much more efficient with EC2. One of the problems with EC2, t-shirt size instances. And you can't carve that up. You can't thin provision EC2. However, if you run containers on top of that, you can become more efficient with the EC2 instances that you do have. So a side benefit for Netflix and Titus was a cost savings because they were able to run their EC2 environment more efficiently. So VMware is saying the same argument, that basically if you adopt their Kubernetes compatible solution, VMware PKS, that you can now run your containers on top of VMware and use all of the features that you're accustomed to using, DRS, for overall VM mobility. If you have long-running instances, you can use VMware integrated containers for a Docker-compatible interface. And then, of course, it integrates hopefully nicely with Pivotal Cloud Foundry and that whole, which is, I think, is a curse word, BOSH integration. People have passions about BOSH. If you don't know why, just Google the term and you'll find people are either very for it or very against it. All right, Docker Swarm. Swarm spelled the right way on this slide. Thank you. So, again, Kubernetes has taken up all of the press. I write for techrepublic.com. If I was to write about Docker Swarm by itself, that probably wouldn't get much interest, not from a container orchestration perspective. Docker has announced Kubernetes support, and what they're doing is really interesting. One of the great attributes of Docker Swarm is simplicity. Docker Swarm is designed for developers to run in production. Docker Enterprise Edition in general is designed for developers to adopt this and become operators themselves. They've taken this ideal of simplicity and added it to Docker Swarm for Kubernetes. In theory, it's just a couple of configuration settings, and now your Docker Swarm cluster, because Kubernetes and Docker Swarm form clusters, and inside the clusters there's pods, there are some equal mappings, there's some unequal mappings, but to oversimplify it, is that basically if you have Docker Swarm infrastructure already, you can enable a Kubernetes cluster on top of your Docker Swarm cluster. So it's literally a right-click type of operation, say enable Kubernetes, and now one of the frustrating parts of Kubernetes management is taken care of, which is upgrading and maintaining Kubernetes. you know, companies like Platform 9, Normata, companies I haven't put on the side, make hay out of managing Kubernetes. If you guys remember the early days of Linux, if you remember the frustrations of OpenStack, going from one version of the solution to another one was a pain, and in some cases still a pain in OpenStack. Kubernetes, not too much different. Going from one, Kubernetes is I think 1.10 I think is in preview or beta. So we're very young in the Kubernetes movement. We've heard a lot about it, but Kubernetes just went production. CNCF just graduated to a production project, I think just a few weeks ago. So from a operations perspective, it's not a proven commodity to say that I can go from version 1.1 to version 1.2 to version 2.0. So a lot of these companies where they're adding value, Nomada and Platform 9, and now Docker with Swarm is saying they're promising a seamless experience from an operator perspective. Operating the actual infrastructure required to run these platforms becomes easier if you adopt an overall solution like Docker Swarm. That's about it with the value of Docker Swarm. So other than, you know, promising API compatibility with both Docker Swarm and Kubernetes, that's the Docker Swarm story. More interesting, to me at least, is AWS EKS. It was announced at AWS reInvent 2017. People are really excited about this. Again, if you look at what Netflix has done with Titus, which is to take EC2 instances and become more efficient with it. AWS is promising big things with EKS. EKS is not even in, I think EKS is right now, yeah, it's in preview right now. So most customers don't have access to it, but AWS is promising both private and public cloud Kubernetes management. So in theory, you're getting this hybrid cloud experience directly from AWS. So the AWS Kubernetes cluster is hosted inside of AWS, inside of EC2 instances. So AWS is going to allow you to size your Kubernetes cluster. It's going to be backed by some EC2 instances. They'll install Kubernetes on that. You'll be charged for both the Kubernetes management and the compute needed to run the cluster. But in theory, that cluster can control resources, that pods that exist inside of AWS. So pods based on EC2 and pods on your private data center. AWS doesn't like to use the term hybrid cloud at all, but in theory, this is a hybrid cloud where you're having resources on your private data center managed by a Kubernetes cluster living in AWS. That is the promise. Again, it's in preview, so I can't comment one way or another if that's the actual effect. What AWS does have in production, and they still push it pretty hard, is their ECS service. It's the Elastic Container Service, which again is backed by EC2 instances. It has a separate API than Kubernetes. This is important. You know, AWS is known for this lock-in. They give you a service that's so great that you use it, you adopt it, you build a application and business on top of it. Google or Azure or Rackspace or any one of these other companies come out with a competitive service. You can't move to it because you're locked into the AWS API. ECS is similar to that. If you want cloud-based containers on the biggest cloud provider in the world, your only production option right now is ECS unless you went the route of Netflix and adopted your own container platform. You can do that in a Kubernetes distribution. You can go to OpenShift. You can go to VMware and go PKS and deploy these things and just consume AWS as an infrastructure as a service, this is where the driver's at. It commoditizes the cloud. The API to your cloud becomes Kubernetes instead of the AWS API or the Google Compute API or the Azure API. You're programming to Kubernetes, and Kubernetes democratizes the cloud. You can run, I don't care if the VM is running on VMware vSphere. I don't care if the container is running on VMware vSphere. I don't care if the container is running on EC2. I don't care if the container is running on Google Compute. It's a container. It's managed by Kubernetes. Kubernetes controls where the workload is placed. Just as long as I program to Kubernetes, I'm fine. ECS doesn't give me that flexibility. That's the big drawback of ECS. All right, we're coming to a close. And you guys haven't asked questions, so maybe we'll get back on track a little bit. No, I'm still a minute over. All right, so Azure Container Services. There's not a lot to say about this. This is like, surprisingly, we don't give Microsoft credit. This is like the first cloud compatible, like Microsoft announced out the gate, their container service is based on Kubernetes, and it's Kubernetes. Not much to add. Kubernetes managed service. It is backed by Azure VM instances, pretty straightforward. And the same thing for Google Cloud. You would expect this. I almost forgot to add them, but this is a proper presentation. Google Cloud supports Kubernetes. So again, proper container service based on Kubernetes. The cluster lives in Google Cloud. You can use that to run. You can add. You set up the networking VPN, and you can manage pods that exist anywhere. It's Kubernetes. So this may sound like a commercial for Kubernetes, but the reality is that Kubernetes has taken pretty much the air out of everyone's sail. Everyone has started to back it, from Mesosphere to Docker Swarm to even AWS. All of the major cloud providers are part of the CNCF, the Cloud Native Compute Foundation, which hosts the Kubernetes project. You want to find out more about me, thectoadvisor.com. On Twitter, I'm at CTOadvisor. If you guys have any questions, I'll be here most of the day. Thank you.
Thank you.
So next up is Datrium.
What do you want to use? Let me see. Okay.
Okay, yep, sure.
Europe one is in the same. Or rather,
Yeah, but the live stream will pick it up even if you're there. So good. Yep. Good.
Okay. Hey, how are you doing? Good? Good. Just since we are a small setting here, How many are managing infrastructure here in any shape or form? No? One, two. How many are in the application space? Application development? Management. Any others? No? Any other areas? No? Okay, so hopefully, it's I want to give you a session where I'm not just trying to sell you my solution, right? What I'm selling. I actually want to talk a little bit about the industry and the evolution of the data center, and make sure that I put things in context and not just present a solution. So, but of course, I'm here as part of as a vendor, Daydream, and we sell what's called a distributed virtual solution. We call it DVX, and it has multiple different components to this solution that I will cover during this session. But it's compute, it's primary storage, it's secondary storage, data management, data protection, security, scale out, cluster management. There's a lot of terms here to talk about. But I want to really go back in time and unfold what really people are talking when they talk about convergence and hyper-convergence and what is happening on the market and why are we doing what we're doing today. And then I'll talk a little bit about the evolution of this model. So if you remember, if you have ever managed infrastructure and data centers, applications used to run bare metal, right? You deploy the guest operating system, either Linux or Windows, on the server, and you would install the application on top of that, and the application would live just on hard drives, right? We had local hard drives in each one of the servers. And the world was good. We couldn't really manage at scale, but it managed individually. But then came along a company that changed the data center and how we deploy infrastructure. They invented something called the hypervisor. I don't need to say the company was VMware, right? The first one. Nowadays, VMware is not even in the business of actually virtualizing x86 instructions. Intel is doing that with VTX, and VMware manages the virtualization layer in Intel. With the hypervisor, we were able to start putting all these applications that were running inside our data centers in these called virtual machines or self-contained environments. And we were able to have many of those inside servers, getting greater consolidation. And with Intel producing better and faster processors, we'd have more and more of those. With that, we now started to use full capacity of those servers. The problem with that is that those hard drives that were in the servers were not good at providing performance that we needed. But then came along a feature from VMware as well that completely changed the data center in many ways. I clearly remember the first time I saw a vMotion, a virtual machine running an application. For those that are not in infrastructure space, I'm talking about something that happened probably 15 years ago, moving between servers in the data center while keeping it running. So the vMotion feature changed the data center in many ways. Now you could migrate applications between servers. The problem is that to use vMotion, you needed something called a shared storage, or as we all know today, a SAN. A SAN, it's a shared storage that is providing the same bucket of storage to all the servers at the same time. The SAN already existed, but it was not very prevalent because there was no need for it. It was more like used as a NAS, like a storage files and so on. But now with vMotion, the SAN became very important. Everybody needed a SAN, and that's why it became so. You have many companies out there that built their story on top of SAN architecture. You got EMC, you've got many others out there, NetApp, and so on. But with more and more consolidation happening, and more applications requiring more processing power and more IOs and more throughput, the SAN was not able to provide all that. And that said, there are other problems with SAN as well. They were very complex. If you ever manage a SAN, there's things like zoning LAN and masks, RAID groups. It's very complex. You need different skill sets to manage all that. In some companies with many different scenes, you need different people to manage all that, right? So it's costly. And at the end of the day, they're not scalable. Some of them you can start small and grow a little bit, but once you need more capacity or performance for your storage architecture, now you need to add another SAN. It's clearly not a good solution, at least for today's infrastructure. But the problem was performance. So with Flash becoming a little bit cheaper, vendors said, why don't we put Flash in the SAN? And let's create a hot tier, a hot caching tier. You know, many of those companies are still out there doing this sort of thing. The real truth is that back in time, caching technologies and algorithms were not really good at that point in time, and they're much better now. But that only lasted a little while because applications needed more performance. And some vendors said, okay, so Flash is now really cheap, and we have things like deduplication and compression. Why don't we add Flash for the entire platform? So they added Flash. And then you see vendors out there like doing well, like VMAX, All Flash, and Pure Storage. There are many different All Flash platforms providing a lot of performance, a lot of throughput for applications. But the real problem here is that the real bottleneck was never solved. Now it's like putting a Ferrari engine inside of a Kia. It's not going to work well, right? The problem is that the two controllers the same architecture presents itself with two controllers were always the bottleneck. You can't give all the performance that you have getting from Flash devices and NVMe and bottleneck everything through those two controllers. That was the real challenge. Some companies looked at that and said, it doesn't make any sense to have Flash inside the SAN, outside the server, remote, and have to go through all the network to provide the data back to the virtual machines. Why don't we put this Flash inside the servers? Kind of back to where we started, right? So some companies, and early on, like Nutanix, one of the very first companies that did that in production environment, Google was doing a long time ago. They looked at this environment and said, why don't we put this Flash inside the server and virtualize those two controllers in each one of the servers as a software stack? So as we add servers with software controller, we are increasing the number of controllers, so we will never run into a bottleneck. That's very clever, right? And it just makes sense to have the Flash inside the server, so you provide the microsecond latency experience, so that you great user experience to the users. We are all used to having Flash or SSDs inside our notebooks. Now, I don't think anybody here has a notebook that has a hard drive inside anymore, like a HDD. It's all Flash, right? And the way this works is these software controllers talk to each other and sort of like architect the solution and where data needs to move, and it's what's called a cluster. So this SSD though was not enough for the amount of capacity that was required, because now SSD was becoming cheaper, but once you're adding in the servers, you can't put all your applications. So they had to add some hard drives, and the HCI solution as we know today, or hyperconvergence as we know today, or the hybrid solution that has Flash and HD was created. And this is what you see from most vendors nowadays, right? It's a combination of software inside the server, and then you have Flash, and you have hard drives, and all servers talk to each other, and the solution happens this way. So when you hear hyperconvergence, this is what we are talking about. Now there are some issues with this sort of technology as well. It solved the many problems. I'm going to talk about them, but also created different issues. First of all, most of the vendors will require you to have a specific hardware or a specific server. They may support different vendors, but they will tell you need to buy this specific solution, and that can be a problem for many vendors. The second thing is, in the same time frame, servers were stateless. What does that mean? It means like if the server failed, you restart that virtual machine in a different server, and the server is accessing that data back online, and it's all good. The data was not compromised. In hyperconverged environments, the servers are stateful. There's data living in all the servers. So as you have a server failure, now you have a data resiliency problem. Now there are some mechanisms to mitigate all that, but the truth is, a server fails, you have data unavailability. So you need to work with that. Also because there's a lot of what we call east and west traffic, or like the traffic between all these software controllers, it's very hard to make it scalable. You hear vendors talking about thousands of servers, petabytes of data. The real truth is there's a bunch of different small clusters that is aggregated through a single pane of glass sort of management interface. And there are other things like this is on its own, it's a silo again, so you need to forklift your applications, your data into that. But there are great things about hyperconversions. They solved the big problem. They made it faster, using no SSDs and flash inside the servers. They removed a lot of the complexity around, deploying SANs and zoning and masking and so on. And some of the vendors went further, and they also automated a lot of the things that we do inside the data center, like patch management, upgrade of BIOS, firmware, and so on. This is all very good. So where do we go from here, right? What do we do next? Why am I here talking? I'm going to say that this is legacy already. So first of all, HCI has been, some companies have been doing for the past 15 years. In tech, 15 years is a long time. And some companies that have been able to assimilate what was good about hyperconvergence, what was good about SAN, and sort of creating a next generation solution. And Datum is one of those companies that was able to look at the problem and sort of try to figure it out. By the way, we have very early engineers from VMware, principal engineers, people that were the first, 20 people at VMware that just left VMware to start this company. Diane Green, VMware founder herself, is an investor in the company, and we also have people from data domain that invented deduplication. They're part of the company as well. So very good pedigree. So we looked at this problem and said, you know what? It just makes sense to be able to scale your data center, adding servers with a flash, with a software stack, because it removes bottleneck that's coming from HCI. It also just makes sense to have flash in the servers, to have that microsecond latency, great user experience to applications and users. What doesn't make sense is to have the servers stateful, to have data living in there, to not be able to scale large. So the solution that we created is a little bit different, has a new twist, and we converge in a different way. So a lot of the things of hyperconvergence we do, it's got data locality, flash, and scale performance, adding servers. But we store persistent data in what's called a data pool or a data tier. So we always have hot data, the data that is being accessed by our applications, sitting in flash, fully deduplicated, fully compressed, and a copy of the data is always stored here, erasure coded, heavily protected in this tier. So what does that make? Essentially is first, servers are stateless. There is data here, but if I lose this server, all I need to do is upload this data into new servers. It happens automatically, dynamically. The second thing, that enables me to increase performance adding servers independent of capacity. In hyperconvergent solutions, you buy that server that has compute and has storage. If you want to add more storage, you need to add more compute. If you don't want to add more compute, you need to add more storage. It doesn't make sense. You need that independence. Enables you also to leverage existing infrastructure in your data center. So give you the same speed and benefits of hyperconvergence, but using your servers. You don't need to buy servers from us. You can bring your own existing servers, and there's no HCL. Basically, anything that is accepted by VMware hardware compatibility list will be accepted. Some some servers will be very old, like 5, 6 years old. They might have some RAID cards that are not compatible, but for the most part, anything is accepted, and you can grow from there. And then because of the infrastructure, we have what's called north and south communication. We can do large clusters. But the interesting thing here as well, here at the top you have your servers, and you have flash. It's all flash here. So you essentially have an all-flash array. Everything is running from flash. This is your primary tier. This is your tier 1. At the bottom, you have a heavily optimized storage solution for your backup. This is your backup. This is your secondary storage. So you have a primary and a secondary storage. Oh, do I need a third-party backup too? It's up to you. Now we partner with vendors, but if you're putting everything in your data center on Datrium, you might not need. The reality is that in large data centers, you might have hundreds of different solutions. You might already have your backup tool, your favorite backup vendor, and we will work with them as well. And this is what Google and Amazon, the type of infrastructure that they're using today. They are not using hyperconvergence anymore. It didn't work for them because of the scalability. Now they need to move performance independent of capacity. I actually thought about removing Facebook icon from there because it's not very good to talk about Facebook right now. But the reality is that if you look at Open Compute and Bryce Canyon and everything they're doing about with OpenRack it's everything going this way, this model. So we are a virtualized infrastructure for virtualization. We do also support bare metal. We do primary data management and have all the features that you'd expect, and always on the duplication, compression, erasure coding, and so on. We are secondary data protection. We do your backup, we replicate, we do all that, and we have offsite data protection. And if you are a VMware customer, of course you'll be very familiar with our UI. It just integrates into vCenter and the single pane of management for your entire organization. So we knew our solution is the most scalable and the fastest in the world. But just we know when doing micro benchmarks is not enough. So we wanted to go and test and validate. So we partnered with Dell, and we did the biggest benchmark at scale in history. We did 128 servers and 10 data nodes in a single unified data center infrastructure, a single pool, a single everything together, right? And with fairly old servers, cheap SSDs on the servers, and with all the data features turned on, everything they would expect that you would run in a data center. Whenever we see benchmarks out there, we see a lot of companies saying, oh, we achieved that, but then you see oh, the duplication was disabled, compression was disabled, and oh, we're doing just protection with 2 copies. Come on, guys, this and ladies, this needs to be a real world thing. So we partner with Dell and Intel, and we hired a company called IOMark to do this benchmark. I'm not gonna skip explaining how the benchmark works, and I can come talk to me later. But basically, the fastest, previous world record was an IBM all-flash array that did 1600 IOMark VMs. The world record for hyperconvergence was vSAN with Optane SSDs. It's a very expensive 3D crosspoint drives, flash devices. They did 800. Datrium did 8,288. It's a different ballpark, a different world, right? It's a whole new level of performance that you're getting with our technology. We just won an award, the best storage technology for 2017. Over half of the this is like the Oscar of storage technology, right? Just over half of the judges gave us the first place. Plenty of customers already using it in all sorts of verticals. Finance. I don't know if there's anyone in finance here. I'm in New York. I gotta talk. I'm from California, but originally from Brazil, but I live in California. Healthcare. There's a lot of things happening there. But I also mentioned. How are we on time, by the way?
Yeah.
You're good?
Yeah,
okay.
good.
but I also mentioned, you know, if you look at that, I talked about tier 1 HCI. I talked about scale out backup, the secondary tier, right? I didn't talk about CloudDR, and that's where I want to spend a little bit of time to explain to you what we do. So we all know iCloud, you know, iPhones. Not sure how many on Android here, but it's fully integrated, right? You don't have to say, hey, back up my data to iCloud. It's automatically there. It happens seamlessly for you, and the data is fully protected wherever, you know, wherever Apple decides to put it. Now we know it's Google, but it's there. For enterprise, a little bit different. You want to make sure that, you know, there's data sovereignty and all that. You need to know how it's protected. But overall, you want to have the same experience when you're backing up your data to the cloud. And that is the approach that we took when we integrated our CloudDR with AWS. So it's a as-a-service solution. The only thing that you have to do is provide your credentials in our user interface. So there's no separate backup tool that you need. There's no gateways that need to be configured. WAN accelerators, we have full deduplication across the wire to make sure that everything works seamlessly. It's highly efficient in the sense that we do this deduplication. There's no full backups. It's always incremental. You know, we're also concerned about costs. Not only to move the data, but the real cost with AWS when you store data there is the egress cost. How much does it take to bring your data if you need to bring data back? And it goes directly into your primary storage. You know, if you use a third-party tool to do backups, now generally speaking, it's a backing up from your primary storage, going to their appliance like a scale-out backup vendor, and then from them it goes to the cloud. On the way back, same thing. You need to hydrate from the cloud, put in this backup vendor, and then move to the primary storage. Sort of like a very cumbersome process that because we have end-to-end visibility of the workloads and the VMs, and we do understand VMs, we can do that seamlessly to you. We actually even talk about do not restore, restart. So basically when you hit restore, it happens just instantaneously for you. Some of the use cases for that, of course, consolidated backup from multiple Datum systems. You can recover to on-premise, so it's like your offsite backup. They automatically recover. And moving forward, we're also going to provide recovery to cloud. So you might have a single data center, and you want to make sure that if the data center goes down, you're able to reinstantiate those virtual machines or that backup in a cloud service, be that on AWS, on Azure, or anywhere else that we are. Today we're only going to provide AWS. Moving forward, there are other options as well. But in my session abstract, I also talked about why innovation doesn't stop here. Right, so this is what we are offering today. But you're starting to hear more and more people talking about NVMe over Fabric. That's sort of the new technology for providing data access or data repositories. The real truth is we have some customers that have been already using NVMe on the servers for over 2 years now, providing very great performance for on the servers. But over time, we already have an all-flash data nodes, but over time, NVMe will also be required here. The problem with NVMe is it's a one-to-one relationship. You can't, there's no way to have, and it's very fast, so it doesn't make sense also to have a controller in front of NVMe drives, because you would be bottlenecking everything. We believe that we are in an extremely great position because we do this distributed reverse coding from the servers to the drives. We will be able to provide NVMe type devices for organizations in a much, I wouldn't say better, but like in a more seamless way than other vendors will in the future. Because first, we are a software controller. Everything goes from the software controller to the NVMe devices. We're able to do erasure coding and distribute data. There's no bottlenecks. And because of that, we'll be in a much better position to tackle new technologies as well as they come. With that, thank you. I know it was a lot.
Thank you.
All right. If you're interested, talking more, learning more, how we can help your organization, myself and John will be at the table outside. Thank you.
So we'll have a break now.
Yeah, we're gonna have a break and we're gonna start again at 11:25 with Scott Lowe is going to talk. We had a bit of a few changes in the agenda because of some disruption to travel, so we had to reschedule a few things. So we're going to be back here at 11:25. Scott Lowe is going to present. Then we have Dean presenting at 11:50, and then we have lunch at 12:35 until 13:30.
I think there's coffee and drinks on that side.
Yeah.
And you can go visit the sponsors in room
803.
803.
Yeah, absolutely. So we're going to move, grab a coffee or something and go to 803. We're going to be all together. The restrooms are on this side. Ladies on the left side and gentlemen on the right side. Just past the reception.